When dealing with small motors and lights, the question arises whether the ridged wire consistently indicates the neutral conductor and the printed side indicates the hot conductor. The answer is not necessarily. While the ribbed wire may sometimes be used to indicate the neutral conductor and the printed side the hot conductor, this is not a universal standard. It's important to recognize that wiring conventions can vary depending on the manufacturer and even the specific product. Relying solely on the presence of ribs or printing to determine polarity can be misleading and potentially dangerous. To accurately identify the hot and neutral conductors, it is crucial to refer to the specific product's documentation or markings. The manufacturer's instructions will provide the correct information for that particular device. This information may be found on a label affixed to the product or within the included documentation. If the product documentation is unavailable or unclear, it is recommended to use a multimeter to test the conductors. A multimeter can accurately determine which conductor is hot and which is neutral. When using a multimeter, exercise caution and follow all safety procedures. It is also advisable to consult with a qualified electrician if you are unsure about the polarity of the wires. Incorrect wiring can lead to electrical hazards including shocks, fires, and equipment damage. Therefore, it's always better to err on the side of caution and seek professional assistance when needed. Understanding basic electrical concepts can help in identifying and working with electrical wiring safely. Firstly, understand the difference between alternating current AC and direct current DC. AC is the type of electricity commonly used in homes and businesses. Secondly, learn how to identify the hot, neutral, and ground wires. The hot wire carries the electrical current, the neutral wire returns the current to the source, and the ground wire provides a safe path for electricity in case of a fault. Thirdly, be aware of the voltage of the electrical system. In the United States, the standard voltage for residential wiring is 120 volts. Higher voltages, such as 240 volts, are used for appliances like ovens and dryers. Fourthly, always disconnect the power before working on any electrical wiring. This can be done by turning off the circuit breaker or removing the fuse that controls the circuit. Fifthly, use insulated tools when working with electrical wiring. Insulated tools help to protect you from electric shock. Sixthly, never work on electrical wiring in wet conditions. Water is a conductor of electricity and can increase the risk of electric shock. Seventhly, inspect wiring for any signs of damage, such as frayed insulation or loose connections. Damaged wiring should be repaired or replaced by a qualified electrician. Eighthly, follow all local electrical codes and regulations. Electrical codes are designed to ensure the safety of electrical installations. Ninthly, if you are not comfortable working with electrical wiring, it is best to hire a qualified electrician. Electrical work can be dangerous, and it is important to have it done properly. Tenthly, remember that electricity can be dangerous, and it should be treated with respect. By following these safety tips, you can minimize the risk of electrical shock and other electrical hazards. Additional information to keep in mind includes wire colors that are often used to identify different conductors. Black wires are typically used for hot wires, white wires are typically used for neutral wires, and green or bare copper wires are typically used for ground wires. However, it is important to note that these color codes are not always followed, especially in older wiring systems. Therefore, it is always best to verify the polarity of the wires using a multimeter or by referring to the product documentation. Another important safety consideration is the use of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electric shock by detecting small changes in the electrical current. When a GFCI detects a ground fault, it will quickly trip the circuit, cutting off the flow of electricity. GFCIs are typically required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. Regularly test GFCIs to ensure they are functioning properly. To test a GFCI, simply press the test button on the device. The GFCI should trip, cutting off the power to the circuit. To reset the GFCI, press the reset button. If the GFCI does not trip when the test button is pressed, it may be faulty and should be replaced. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical wiring from damage caused by overloads or short circuits. When the electrical current exceeds the rated capacity of the circuit breaker will trip or the fuse will blow, cutting off the flow of electricity. Circuit breakers can be reset by flipping the switch to the off position and then back to the on position. Fuses must be replaced with a fuse of the same type and rating. It is important not to use a fuse with a higher rating than the circuit is designed for, as this can create a fire hazard. When working with electrical wiring, it is also important to be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit or other electrical fault. Arc flash can cause severe burns, blindness, and even death. To protect yourself from arc flash, it is important to wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and flame-resistant clothing. It is also important to maintain a safe distance from energized electrical equipment. Regularly inspect electrical equipment for any signs of damage, such as cracks, frayed wires, or loose connections. Damaged equipment should be repaired or replaced by a qualified electrician. In addition to the above safety tips, it is also important to follow all local electrical codes and regulations. Electrical codes are designed to ensure the safety of electrical installations and to prevent electrical hazards. Local electrical codes may vary depending on the location, so it is important to be familiar with the codes that apply to your area. Also, remember that electrical work can be dangerous, and it is important to have it done properly. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician. A qualified electrician has the knowledge and experience to safely and effectively perform electrical work. The NEC, or National Electrical Code, provides comprehensive guidelines for safe electrical installations. Some relevant sections include Article 200, which covers the use and identification of grounded conductors. Article 210 addresses branch circuits, including requirements for the number and type of outlets on a circuit. Article 250 covers grounding and bonding, which are essential for electrical safety. Article 300 provides general wiring methods, including requirements for cable installation and protection. Article 310 addresses conductors for general wiring, including ampacity and insulation requirements. For example, NEC Table 310.16 provides ampacity ratings for conductors based on their size and insulation type. When selecting conductors, it is important to choose the correct size and insulation type for the application. The ampacity of the conductor must be sufficient to carry the load current without overheating. The insulation type must be suitable for the environment in which the conductor will be installed. Also, NEC Section 110.3 B requires that equipment be installed and used in accordance with its listing and labeling. This means that you should always follow the manufacturer's instructions when installing and using electrical equipment. Lastly, NEC Section 110.12 requires that electrical work be performed in a neat and workmanlike manner. This means that wiring should be installed neatly and securely, and that all connections should be properly made. In summary, while the red or printed marking on wires may sometimes indicate polarity, it is not a reliable universal standard. Always refer to the manufacturer's documentation or use a multimeter to verify polarity. Follow safe electrical practices and consult a qualified electrician if you are unsure about any aspect of electrical wiring.